Pumping units, like that one, have been used for decades to help us get oil out of the ground. Millions of barrels of crude oil are pumped daily by these units. The oil that is pumped here might end up anywhere, as any number of end products. But before any of this crude is trucked or piped to a processing facility, it's first separated and stored in tanks in the field where it's produced. And it's that part of the process, the separation and storage of crude, that we're going to look at in this module. This is the first section of a two-section module covering lease tank gauging and testing. This section deals with the components of a typical field separation and storage facility. The accurate measurement of oil, natural gas, and water produced each day on our company leases is vital to the company. These measurements are important because an accounting of these volumes must be made to the producer, the buyer, royalty owner, and any regulatory agency involved with the lease. Further, pipeline companies pay only for pipeline quality oil, having little or no impurities, commonly referred to as basic sediment and water, or BS and W. Accurate measurement then assures that our company receives the correct revenue for what it sells. Now, as mentioned earlier, crude oil has many impurities mixed with it. Water and basic sediments, such as sand and clay, etc., are the most common. However, other impurities, such as minerals, paraffins, or substances which can form emulsions, may also be found in the crude. Before selling this crude oil, it must be treated to remove as many impurities as possible. Field separation and treatment of crude oil will vary depending on the kind of oil and types of impurities. However, most field locations will include the following separation and storage equipment. In the field, pumps and piping are used to move fluids throughout the separation facility. In some locations, pipelines, referred to as gathering lines, move the natural gas and crude oil to sales stations. Chemicals are added to well fluids to help neutralize the emulsions so the oil and water can separate. A chemical injector is commonly used to inject these chemicals downhole or at the surface. A manifold, or header, allows the lease operator or pumper to direct the flow from each well. A production separator separates gas and liquids. There are two-phase or three-phase separators. A two-phase separator just separates natural gas from the liquids. A three-phase separator, on the other hand, separates natural gas, oil, and water. A test separator allows the lease operator or pumper to conduct well tests on each well. A gas meter is used to measure the volume of natural gas delivered from the lease. Most of these meters will be orifice meters with chart recorders. Heater treaters located at the facility are used to break up emulsions through the use of heat, chemicals, and gravity settling. Additionally, a gun barrel may be used to separate oil from water through gravity settling. It can be aided by the use of chemicals and heat. In most instances, oil is produced with water. This water is commonly salt water. Salt water disposal tanks are used to store this water prior to disposal or re-injection into the reservoir. A lease tank provides temporary storage for crude oil. It also provides a way for the crude to be measured and tested prior to selling. When there is more than one tank on site, the tanks are commonly called a tank battery. Once crude oil is processed, it is then piped to one or more lease tanks. Now, lease tanks are also called by other names, such as stock tanks, production tanks, etc. The number and size of these tanks at any one facility will vary depending on daily production and frequency of pipeline or transport runs. The total storage capacity of a tank battery is usually 3 to 7 days of production. Before a lease tank is put into service, it has to be strapped. Strapping involves measuring the dimensions of the tank so that the volume can be accurately computed. Oil volume is usually computed for each 1/4 inch interval of height in the tank. A tank table showing the volume of oil at each interval of height is prepared and kept in the doghouse or field office. Strapping a tank assures both you and the purchaser that the tank contains an accurate volume of oil. However, if one of these tanks should be dented, bulges, or begins to leak, then the inside capacity of the tank has been changed, and accurate measurement cannot be taken until the tank has been repaired and restrapped. Let's take a look at a typical lease tank and its components. Lease tanks are cylindrical containers with a top and bottom. Usually they are constructed of bolted or welded steel. However, some fiberglass tanks are being used at low-volume leases or where crude oil contains corrosive impurities. Tank sizes can range from 100 to 20,000 barrels, but most tanks are 1,000 barrels or less. A typical lease tank has several components besides the tank itself. First, there is a set of stairs leading to the top of the tank. If there is more than one tank on site, a catwalk is used to provide access to all other tank tops. On the top of each tank is a thief hatch. A thief hatch is a small door which enables the gauger to see inside the tank, gauge the tank, and collect samples without opening valves. A fill line is the line which brings the oil to the tanks from the separation equipment. A vent or relief line is usually connected to a small dome or cap on the tank top. This line is used to vent gas pressure to the atmosphere. It is also equipped with a stack or vent valve for regulating pressure inside the tank. Sometimes, when there is more than one tank on a lease, an equalizing line will be put between the tanks to allow the tanks to fill equally. Many tank batteries will also have overflow lines which are used in emergencies when one tank has been overfilled. Now, the overflow line should not be confused with an equalizing line. The overflow line is near the top of the tank, and the equalizing line is near the bottom. A roll line is used for agitating or rolling tank fluids. This is usually done for two reasons: to uniformly mix the chemicals and tank fluids when treating the bad tank of oil, or to clean out tank bottoms by mixing up tank fluids and then pumping these fluids back through the field separation equipment. A loading line is located near the bottom of the tank. This provides a location for tank trucks or LACT units to draw oil from the tank. Located on the loading line is a valve. This valve is normally kept closed so the tank can be filled between runs. This valve is sealed with a lock, or more commonly, a boxcar seal. A swing line may occasionally be used when the tank bottoms, or settlings, are too high for normal running of the tank. By raising the swing line level, only good oil will be drawn off. Never, however, move the swing line without checking with the field foreman. One final piece of equipment on a lease tank is the inspection plate, or cover. Now, this door allows access to the inside of the tank for periodic cleaning and inspection. This concludes our first section covering the components of a typical field separation and storage facility. Now take some time to review your manual. Look at this section of the videotape again if necessary, then fill in the blanks and answer the questions in section 1 of your student manual. In our next section, we will look at various tests and equipment used to conduct those tests on crude oil. Crude oil is bought and sold by volume, with a 42-gallon barrel as a standard unit of measure. Now, it's important to understand that this standard barrel is considered to exist at standard conditions of 60 degrees Fahrenheit with no BS and W impurities. Oil expands and contracts with temperature. So, a barrel of oil will occupy a larger volume at 80 degrees Fahrenheit than it does at, say, 40 degrees Fahrenheit. That means that the actual level of oil in this barrel, as well as in a lease tank, will vary greatly depending on temperature. And if you add in BS and W impurities, well, it becomes apparent quickly that measuring crude volume is not always an easy task. At today's oil prices, a lot of revenue can be lost if crude is inaccurately measured. In this section of the module, we'll look at the process and equipment used to properly gauge and test lease tanks. This is the second section of a 2-section module covering lease tank gauging and testing. In this section, we'll look at the tests and equipment used in those tests. The process of gauging and testing a tank is commonly referred to as working a tank. The person who works a tank is a gauger. Basically, there are 2 types of gaugers: a representative of the operating company, or seller, and a representative of the pipeline company, or buyer of the oil. Both gaugers have the same responsibilities and work together. These responsibilities include gauging lease tanks before and after a run to determine volume of shipment, determining oil temperature at time of run, collecting samples of oil for testing, conducting gravity and BS and W tests, preparing run tickets, and maintaining appropriate records for accounting and regulatory agencies. As our gauger, whether you are actually gauging and testing the tank or just witnessing, it is your responsibility to assure proper procedures are strictly followed. Your job as witness is important because of possible discrepancies. For example, if you gauge a tank early in the morning and the buyer's gauger does not arrive until late afternoon, conditions could change, and their test results could differ from yours. This causes added costs and delays. Let's take a moment now to look at some of the equipment you will need to work a tank, and make sure you have everything before you go to the tank battery. A gauger's tape is a measuring tape much like one you would use around the house. This device, called a fief, is used to collect a sample of oil from the tank. You'll need a thermometer to measure the temperature of the oil. The most common thermometer is a wood-back cup case thermometer. A hydrometer is used to determine the oil gravity. The heated centrifuge is a device used to spin heated samples of oil to accelerate the settling process. Centrifuge tubes are graduated glass containers used to measure the amount of BS and W in oil. The composite sample container is used to hold an oil sample while conducting tests. Water cut paste is used to determine the water level in the tank. The paste is water sensitive and changes color when it comes in contact with water. A solvent is used to cut the oil sample when conducting the test. Common solvents used are Stoddards or toluene. However, kerosene and white gasoline are also used to cut oil samples. Remember, all of these solvents are flammable and must be used with extreme care. Other miscellaneous equipment which you should have with you include a hard hat, ruler, clean rags, a memo book, pencils, and tin snips for cutting boxcar seals and loading valves. Now, the recommended steps for gauging and testing a lease tank are included in your student manual behind Section 2. Your instructor will lead you through these steps at the appropriate time in your training. However, at this time, let's look briefly at how a tank is worked. When you first arrive at the tank site, be sure to notice anything unusual. Look first for anything which might present a hazard to you, such as leaking gas or oil. Then check the condition of the tank. Be sure to note any dents, bulges, loose fittings, and so forth that might be apparent. Be sure to check the tank number to assure that you're gauging the right tank. Once you're sure you're gauging the right tank, you'll want to isolate the tank by closing the isolation valve. If you're using a heated centrifuge, go ahead and turn the heater on now. This will save time later. As you climb the stairs to the top of the tank, be sure to use the handrail. Using the handrail is important for two reasons. The first, obviously, is to provide you with balance as you climb the stairs. Less obvious, though, is the fact that as you grab the handrail, you ground your body, eliminating any potential spark from static electricity, which could create a fire hazard. Once you reach the top, close the top valves. If it has been determined that hydrogen sulfide, or H2S, is present in the area, be sure to wear the proper breathing apparatus. In any case, be sure to stand upwind of the thief hatch as it is opened. Take a good look at the oil. Is it boiling? If it is, you'll have to come back at a later time to work the tank. If the oil is calm, you can go ahead and work the tank. It's a good idea to go ahead and suspend the thermometer in the oil now, before you take the oil sample. This allows the thermometer to stabilize as you take the sample, and ultimately saves time later. Lower the thermometer slowly into the oil, stopping at mid-level in the tank. Keep the thermometer away from the wall of the tank itself. Fasten the thermometer rope securely to the thief hatch before you go on to take a sample. Always be sure to use a clean, dry thief when taking a sample. Open the thief's rotating valve, set the trip, and lower the thief through the thief hatch. Once the thief is at the correct level, trip it to take a sample. Raise the thief slowly, allowing excess oil to drain back into the tank. Using the sample in the thief, we are now ready to determine the API gravity. Check the hydrometer for cleanliness and any defects. Carefully place the clean hydrometer in the sample, keeping the hydrometer away from the thief wall. After leaving the hydrometer in the sample for 3 to 5 minutes, depress the hydrometer into the sample 2 scale divisions and release it. This helps to assure the accuracy of the reading on the hydrometer. Now read the gravity and temperature and record these measurements in your memo book. After you've cleaned the hydrometer, return it to its protective case. Before you take the BS&W sample, you'll need to empty the contents of the thief into the composite sample container and clean the thief with solvent. After drying the thief, open the thief's rotating valve and extend its trip rod. Lower the thief slowly to the bottom of the tank or datum plate and trip it to take the sample. After removing the thief, Determine the BS and W level by measuring from the tip of the trip rod to the top of the BS and W level in the thief, and record this measurement in your memo book. It's also possible to measure BS and W by collecting a sample through a cock valve located below the pipeline connection, or by gauging the tank with water-cut paste applied to the gauger's tape. After you measure the BS and W, it's then time to gauge the actual oil in the tank. This is done by using a gauger's tape. Lower the tape slowly into the oil from the reference point on the thief hatch. Be sure to ground the gauge line to the thief hatch to eliminate any potential spark hazard that might arise from static electricity. Stop lowering the gauge tape when the plumb bob just touches the datum plate, making sure the plumb bob is vertical, or you'll get an inaccurate measurement. Withdraw the tape and quickly read where the oil wets the tape. After recording the measurement, repeat the process. This process is repeated until two identical measurements are obtained and recorded. After the level is measured, then you remove the thermometer suspended earlier and read it immediately. Then record this temperature in your memo book. Wipe the thermometer dry and stow it away. Close the thief hatch and clean up around the area. Carefully descend the stairs to prepare for the next step, the centrifuge test. Using the proper centrifuge tubes, prepare 2 samples. Fill each of the tubes with equal quantities of oil sample and solvent. After inserting stoppers, shake the tubes to evenly mix sample and solvent. Place the samples in the centrifuge trunnion cups, allowing them time to heat up. Turn the centrifuge on and let it run for 3 to 10 minutes. Allow the centrifuge to stop by itself. Never try to slow down a centrifuge with your hand or other object. Remove the samples and read the percentages of BS and W in the tubes. Record the readings in your memo book. If the readings in the 2 sample tubes are not the same, repeat the test. Otherwise, clean the centrifuge tubes and return them to the case. Now it's time to run or empty the tank. First, cut the seal on the loading valve. Usually this is a boxcar seal. Open the loading valve to transfer the oil. Emptying the tank will take a while, anywhere from 30 minutes to as much as a few hours. When the tank is empty, close the loading valve and have a pipeline gauger attach a new seal to the valve. Note the seal number in your memo book. At this point, you'll re-gauge the tank, repeating the gauging steps shown earlier. After you've taken the closing gauge, complete the run ticket. The information that you'll need to record on the run ticket includes the lease name and number, the tank number, the opening and closing gauge, the test results, the time and date the tank was worked, and the gauger's signatures. This concludes our module on lease tank gauging and testing. In it, you've seen the components which make up a field separation facility and the basic methods of testing and gauging a lease tank. Take a moment now to review the section just completed. Look at that section on the videotape again if necessary, then fill in the blanks and answer the questions in Section 2 of your student manual. Remember, pipeline companies, producers, buyers, royalty owners, and regulatory agencies all require accurate oil volume measurements for their specific accounting needs. It is very important, therefore, that your measurements are accurate and complete. The revenue our company receives from the oil depends entirely on you.